Hi friends, in this video we are going to learn about Einstein's coefficients A and B. We know that light is absorbed or emitted by atoms during their transition from one energy state to another. Let us consider an atom has two energy levels E1 and E2. When the atom is exposed to the light, that is photon of energy, there are three distinct processes takes place. They are absorption, second one is spontaneous emission, third one is stimulated emission. The first process, absorption. An atom in the ground state absorbs the photon of radiation of energy and goes to excited state. Here, upward transition takes place. This process is called as absorption. Important notations which involved this theory. R suffix 12 is the rate of absorption. Here R is nothing but the rate. Rate means change in quantity by time. 12 in the suffix refer the energy level 1 and energy level 2. So, the transition takes from energy level 1 to 2. So, that is absorption. The 12 refers absorption, R means rate. Next, R21. R means rate. 21 is the transition from energy level 2 to energy level 1, that means E2 minus E1, E2 to E1. E2 to E1 may be emission. So, R12 is absorption, R21 is emission. In general, you can easy to remember the 12 is upward transition, absorption, 2 to 1 is downward transition, is nothing but emission. The next symbol is rho. Rho is energy density of incident radiation. This density factors involving only in the absorption and stimulated emission process, not in the spontaneous emission, because in the spontaneous emission is non-radiative transition. So, we should not consider. Next, N1. N1 means number of atoms in the ground state. Here 1 refers ground state, that is E1, 2 refers excited state. So, N2 can be easily noted that number of atoms in the excited state. Then A21. A is Einstein's coefficient, that is the probability of spontaneous emission transition per unit time. This is a constant A21. 21 refers emission. So, I refer emission here. A is spontaneous. B is stimulated process. 1 2 is absorption. So, stimulated absorption, generally we say it is absorption. So, B12 is probability of absorption transition per unit time. Then what is B21? Yes, the 21 is B stands, B is stimulated, 21 is emission. So, stimulated emission transition per unit time. So, here A and B are Einstein's coefficients. How to remember these notations? Here R is rate. What is meant by rate? Rate is change in quantity by time. A is spontaneous. Here we are not using any kind of photon. Without triggering, the electron jumps from higher energy to lower energy. So, that is called emission process, spontaneous emission. So, A is spontaneous, 221 is emission. Then stimulation. In both cases, absorption and stimulated emission, photons are used. The external trigger pulses are used in order to move that atom from ground state to excited state or excited state to ground state. So, here B refers stimulation, 12 refers ground state to excited state. So, that is absorption. Excited state to ground state, that is 21, that is called as emission. Once again you remember, E1 to E2 means absorption process takes place, that is upward transition. E2 to E1 is downward transition, the emission process takes place. Here let us see that how Einstein's coefficient for absorption get. If there are many number of atoms in the ground state, then each atom will absorb the energy from the incident photon and goes to the excited state. Then the rate of absorption is proportional to the some factors. The first factor is density, energy density of incident radiation. Here R refers rate, 12 refers absorption. We already seen that, isn't it? Next, R12 is directly proportional to the energy density. Then the rate of absorption is directly proportional to number of atoms in the ground state. Then we can write R12 is directly proportional to rho into N1. In order to make it a mathematical expression, R12 is equal to, we introduce a constant, that is B12, then rho into N1. Here B12 is the constant, which is nothing but probability of absorption transition per unit time. Normally, the atoms in the excited state will not stay there for a long time. So, it comes to ground state by two methods. The first one is spontaneous emission and another one is stimulated emission. Now, let us see what is spontaneous emission. The atom in the excited state returns to the ground state by emitting a photon of energy without applying any external triggering. Is very important. Without external triggering, the atom in the excited state returns to the ground state by emitting a photon of energy. This process is called as spontaneous emission. The emitted photons move in random direction. The radiation is less intense. Photons are not in same phase. So, in general, we can call this type of transition is called as non-radiative transition. This type of non-radiative transition is incoherent. Here let us see how to get the Einstein's coefficient for spontaneous emission. The rate of spontaneous emission is R21 within bracket SP. SP stands spontaneous, which is directly proportional to number of atoms in the excited state. Here R21 refers, R is rate, 21 is E2 to E1, that is emission. R21 spontaneous emission is directly proportional to number of atoms in the excited state. The next equation R21 within bracket SP is equal to A21 N2. So, A21 is constant, which is nothing but probability of spontaneous emission transition per unit time. Here, why did we write unit time? Is the rate. The rate means per unit time. Next, the third process is stimulated emission. With external energy, the atom in the excited state returning to the ground state by emitting a photon of energy. Here, for the external triggering, a photon is appeared. It moves to excited state and hits the atom, hence the atom returns back to the ground state. According to Bohr's atom model, when transition takes place from higher energy level to lower energy level, photon is emitted. Now, we have two photons, one is triggering photon and another one is emitted photon. Both are in same direction, same phase and high intense. These are the properties of coherent. So, in this process, laser comes out from that material. So, ultimately we can say the stimulated emission process is the key factor of laser. Finally, we are going to see how to get Einstein's coefficient for stimulated emission. The rate of stimulated emission is depending upon the density and the number of atoms in the excited state. So, that we can write as R21 within bracket stimulation is directly proportional to density and number of atoms in the excited state. After getting the mathematical expression by introducing a constant, R21 within bracket St is equal to B21 rho N2. Here B21 is constant, which is known as probability of stimulated emission transition per unit time. Thus, we got Einstein's coefficient A and B. The next video, we will see how to determine the Einstein's coefficient A and B using Einstein's quantum theory. Thank you.